Now I will introduce our first speaker, who is Shri Manoj Kumar Nayak, Deputy Director, Legal Metrology, Department of Consumer Affairs. He will talk about draft regulations on gas meters under Legal Metrology Act 2009 and the implementation plan. So, Sir has joined services in the year 2004 as a meteorological assistant at RRSL Bhubaneswar, and he worked as assistant director of legal metrology at RRSL Ahmedabad from 2010 to 17, and he worked as deputy director legal metrology at RRSL Guwahati from 2018 till 2021, and he is now deputy director legal metrology in the Department of Consumer Affairs, Krishi Bhavan, New Delhi. He specializes in legal metrology for verification of legal standards.
Namaskar.
Yes, sir. So now I request sir to kindly share his presentation and start his talk. Yes.
Should I start the presentation?
Yes, sir. You can share your presentation.
Share. Just a minute. Yes, sir. Yes, sir. Namaskar, and this is the presentation of gas meter regarding proposed draft rule for gas meter, which is to be included in the 8th schedule of legal metrology general rules. And under section 52 of the Legal Metrology Act 2009, it deals about the power of central government to make rules. And under section 52 clause deals about the metrological controls such as physical characteristic, configuration, constructional details, materials, equipment, performance, tolerance, period of re-verification, method or procedure of test, and the central government can make the rules. And it is proposed on the basis of OIML recommendation number R137 part 1 and part 2 in edition 2012, and this is proposed draft rules for the gas meter. And gas meter is an instrument intended to measure, memorize and display the quantity of gas passing the flow sensor. And gas meter, it is propane and natural gas, the quantity or pressurized quantity of gas that flows via the meter. Gas meters measures a defined volume, temperature under certain temperature, pressure through a meter. The quantity of gas can be expressed in units of volume or mass. And this recommendation applies to gas meters intended to measure quantities of gaseous fuels or other gases. And it is not cover meters used for gas in the liquefied state, multi-phase, steam and compressed natural gas used in CNG dispenser. And the gas meters, various types of gas meters are there. That is volumetric flow rate of gas measured using a range of gas meters, and that are diaphragm meters, rotary displacement meters, velocity type gas meters, head type gas meters, thermal type gas meters, acoustic gas meters. I think some of the paper presenters are from the manufacturing unit, and as I heard, they will elaborate about the diaphragm meter. And diaphragm principle of operation of gas meter. So number one, diaphragm meter. These gas meters have 4 measurement chambers linked together to form a unit that is separated by diaphragm and a deformable wall. And diaphragms are connected by a rotating piston and can also be employed with pulse generators for providing a meter reading. And diaphragm meters are mainly installed in domestic applications because they have especially large range ability. That is maximum flow rate and minimum flow rate, that is ratio is 160. And rotatory displacement meter consists of 2 rotating impellers that move opposite to one another. The impellers are placed inside a housing. The gas volumes can be measured directly since the volume of each measurement chamber is well known. Rotary displacement meters can also be achieve high range abilities like diaphragm meters, and the ratio of maximum to minimum might be goes up to 250. The error curve of rotatory displacement meter is determined by the losses between the impellers as well as between the impellers and housing.
Nayak sir, excuse me. You can just put your presentation in slides, so it is not full screen. You can put it in slides.
Okay, okay, sir.
Yes, okay, thank you.
The calibration of gas meter should be in good operational condition during usage and should possess a valid calibration certificate. It is necessary to perform periodic calibration of gas meters to avoid generating significant errors. The common calibration practice involves setting a short recalibration period for the new gas meters, then performing sequential calibration. Drift between each calibration to be estimated, and users can be determine whether to increase or decrease the calibration interval. And uses of gas meter, they are used in offshore and onshore drilling rigs to detect the major gas quantities. They can be retrofitted to existing rig flare lines to measure the gas volumes. Gas meters are no exception. Gas meters must be in good operational condition and must have a valid calibration certificate. And they are used residential, commercial, and industrial buildings that consume fuel gas supplied by a gas utility. And international practice with gas meter, the initial re-verification period diaphragm type, it is 7 years proposed. For the meters rated air capacity greater than 250 cubic feet per hour, that is 6.8 meter cube per hour. Initial verification period is proposed at 7 years, and for the subsequent re-verification period, it was 6 years in the international practice. And after subsequent re-verification period after 2014, it is reduced to 5 years. And meters rated with air capacity less than 240 cubic feet per hour, that is 6.8 meter cube per hour, qualifying under clause was 10 years, and initial verification was 7 years, but after 13 it is made 6 years, and subsequent verification it is made 8 years. Rotary type gas meters, which is subtype or node pressure body type, that is initial verification period is 20 years, and after 2013 it was made 17 years, and after 14 it was made 16 years. So like that, rotary, turbine, orifice, ultrasonics, fluidic oscillation, vortex, all meters have been almost came to after 14. It is periodic re-verification period is made almost 4 years. And I will show the later on the gas meter which was approved by the Ministry of Consumer Affairs on the basis of international recommendation only, not in the testing inside the country. And the provisions relating to approval of model in accordance with Legal Metrology Act under Section 22, every person before manufacturing or importing any weight or measure shall seek the approval of models of such weight or measure in such manner on payment of such fees and from such authority as may be prescribed, provided that such approval of model may not be required in respect of any cast iron, brass, bullion, or carat weight or any beam scale length measure not being measuring tape which are ordinarily used in retail trade for measuring textile or timber, capacity measure not exceeding 20 liter in capacity which are ordinarily used in retail trade for measuring kerosene, milk or potable liquors. Provided further that the prescribed authority may, if he is satisfied that the model of any weight or measure which has been approved in a country outside India conforms to the standards established by or under this act, approve such model without any test or after such test as he may deem fit. This is the act under section 22. The director is powered for model approval. So in the technical specification, we have two parts are there. Part one deals with the metrological and technical requirements, and part two deals with the metrological controls and performance test. And some technical terms are there, that is flow rate, percent of the actual quantity of gas passing through the gas meter and the time taken for the quantity to pass through the gas meter. This is flow rate Q. And maximum flow rate Q maximum, it is the highest flow rate, and minimum flow rate, it is the minimum flow rate. And transitional flow rate, it is denoted by QT. It is and flow rate which occurs between the maximum flow rate, that is Q max, and the minimum flow rate Q minimum, that divides the flow rate ranges into two zones, the upper zone and the lower zone, is characterized by its own maximum permissible error. So upper zone has the own maximum permissible error, and the lower zone also has own maximum permissible error. And test condition, the metrological requirements, rated operating conditions, values of Q max and QT and Q minimum. The manufacturer of the gas meter should mention the rated operating conditions. The flow rate characteristics of a gas meter shall be defined by the values of Q maximum, QT and Q minimum. And there are ratios and relations shall be within the ranges as stated in the table 1. Q maximum divided by Q minimum, the ratios greater than 50, then Q maximum and QT ratio should be greater than equal to 10. And whenever the Q maximum and Q minimum ratio is greater than 5 and less than 50, the Q maximum and QT should be greater than equal to 5. In accuracy class and maximum permissible errors, gas meters may be divided into three accuracy classes, that is 0.5, 1 and 1.5. A gas meter shall be classified according to its accuracy in one of these classes. The value of the MP is dependent on the applicable accuracy class as listed in table 2. That is, it is based on the flow rate Q. When Q minimum is less than Q is less than QT, the accuracy maximum. First, during the type evaluation and initial verification, error for accuracy class 0.5 is plus minus 1%, and for accuracy class 1, it is plus minus 2%, and for accuracy class 1.5, it is plus minus 3%. It is during the evaluation and the initial verification. And when the Q transitional flow rate is less than equal to flow rate Q is less than equal to maximum flow rate, for accuracy class 0.5, the initial maximum permissible error is plus minus 0.5%, and for class 1 instrument it is plus minus 1%, and for class 1.5 it is plus minus 1.5%. And during the subsequent verification and in service, that is in service, the accuracy class 0.15, the maximum permissible is plus minus 2%, for accuracy class 1 plus minus 4%, and for 1.5 accuracy class this is plus minus 6%. So in service condition, the maximum permissible is almost double the first initial verification. And another term is weighted mean error, WME. The weighted mean error shall be within the values as per the table 3, and flow rate flow rate Q and accuracy class 0.05, it is for the evaluation and initial verification, WME should be plus minus 0.2%, and for class 1 accuracy it is plus minus 0.4%, and for 1.5 accuracy class it is 0.6%. And a gas meter shall meet the following requirements after being subjected to flow, with rate between 0.8 maximum and 0.2 maximum, comprising a quantity that is equivalent to a flow at Q maximum during a period of 2000 hours. This is the durability condition. It should require the flow rates from Qt up to Q maximum a fault of less than or equal to 1.5 times the maximum permissible error applicable during the type evaluation for class 1.5 or 0.5 times. And the part two, the technical specification covers the metrological controls and performance test. Yes, and this recommendation applies to gas meter based on any measurement technology or principle that is used to measure the quantity of gas that has passed through the meter at operating condition. And recommendation applies to gas meters intended to measure quantities of gaseous fuels or other gases. It does not cover meters used for gases in the liquefied state, multi-phase, steam, and compressed natural gas used in CNG dispenser. A metrological controls general procedure is there in the details. It will be not some of the performance test I will talk about. The dry static temperature test. It is the standard applicable is IC 6006822 and object of the test is verification of compliance under the conditions of high environmental temperature. Test procedure in brief, the test comprises of exposure to the specified high temperature under free air conditions for the time specified. The time specified is the time after the UT has reached temperature stability. The change of temperature shall not exceed 1 degree centigrade per minute during the heating up and cooling down. The absolute humidity of the test atmosphere shall not exceed 20 gram per meter cube. When the testing is performed at temperature lower than the 35 degree centigrade, the relative humidity shall not exceed 50%. And temperature upper limit is specified in degree centigrade, duration is 2 hours. In cold influence test, the applicable standards is IC 6006821 and object of test verification of compliance under conditions of high environmental temperature. The test procedure in brief is the test comprises of exposure to the specific low temperature under free air conditions for the time specified. That means the time specified is the time after the UT has reached max temperature stability. The change of temperature shall not exceed 1 degree per minute during the heating up and cooling down. IC specifies the power to the UT shall switch off before the temporary rate. Duration is 2 hours. Dam feed steady test state non-condensing influence test and applicable standards is IEC 60068-278. Object of the test verification of compliance under conditions of high environmental humidity and constant temperature. Test procedure in brief, the test comprises exposure to the specified temperature and the specified constant relative humidity for a certain fixed period of time. The UT shall be handled such that no condensation of water occurs on it. The gas meter shall be subjected 3 times to an accuracy test at reference condition before the increase of temperature, at the end of upper temperature phase, and at the reference condition 24 hours after the decrease of temperature. Relative humidity would be 93% and duration 4 days. Vibration disturbance test applicable standard is IEC 60068-47 and object of this vibration test is verification of compliance under condition of random vibration. And the test procedure is the test comprises exposure to the level of vibration for the time specified. The UT cell subsequently be tested in 3 mutually perpendicular axes mounted on a rigid fixture by its normal mounting means. The UT shall normally be mounted in such a way that the gravity vector points in the same direction as it would do in normal use. where based on the metering principle, the effect of gravitational force can be assumed negligible. The UT may be mounted in any position. For example, the diaphragm gas meter always has to be tested in an upright position for each direction in which the meter has to be tested. During the test, the instrument is not required to be powered off, that is always switched on. And the frequency range is 10 Hz to 150 Hz and total RMS level 7 meter second per 7 meter per second square, and number of axes is 3 and duration for axis is 2 minutes. Mechanicals of this is disturbance test and applicable standard is IC 60068 2/31, and the object of the test is verification of compliance under condition of mechanical shocks. The test procedure in brief is the UT placed it in its normal position of use on a rigid surface. It tilts towards one bottom edge and is then allowed to fall freely onto the test surface. The height of fall is the distance between the opposite edge and the test surface. However, the angle made the bottom and the test surface shall not exceed 30 degrees. During the test, the instrument is not powered up. It is always to be kept on switched on. And the height of fall is 15 mm and number of falls each bottom edge is number 1. And performance test, that is electrical in general, it is radiated RF electromagnetic field disturbance test, and the applicable standard EISC 60610043, and the object of the test is verification of compliance of the UT while being exposed to RF electromagnetic fields. And the test procedure is for the UT is exposed to electromagnetic field having the required field strength level specified, and the field of uniformity is defined in the referred standard. The referred standard, the UT shall exposed to the mounted wall field frequency. The frequency shift shall be performed only pausing the adjust the RF signal level or to show stepwise shall not exceed 1%. In the preceding frequency value, 1% of the preceding frequency value, the dwell time of the amplitude modulated carrier at each frequency will not be less than the time necessary for the UT to exercise and to respond, but shall in no case be less than 0.5 seconds. The expected most critical frequencies, that means clock frequencies, shall be analyzed separately, and the frequency range should be 80 megahertz to 3 megahertz and 26 megahertz to 3 hertz. And in
Sir,
electrostatic
please
discharge.
conclude. Sir, please conclude.
Okay, sir. And for offense and penalties, the section 25 Act penalty for use of non-standard weighter measure. The first offense is for fine up to 25,000, and for the subsequent offense, imprisonment for a term which may extend to 6 months, and also with fine. And penalty for manufacture or sale of non-standard weighter measure. First offense, it is fine up to 25,000. And for second or subsequent offense, imprisoned for a term which may extend to 3 years to fine or both. And penalty for transaction in contravention of standard weight measure, it is 10,000 rupees. And for penalty for use of unverified weighter measure, it is not less than 2,000, which may extend to 10,000 rupees. Thank you, sir.